Hello and welcome to our 18th annual exhibit of hydrogen and fuel cell technology at the Hanover Fair. We've been here since 1995 discussing this technology, its applications, the way it's created and how it's manufactured. There's a lot of details involved, and some of these details, for these details we need specialists, people who come from outside the industry and offer their expertise to us. And there's much expertise to be had. For example, from Owen Hopkins, who's sales director at Entegris, Inc. I'd like to ask him to the stage and join us in the conversation about bipolar plates. Welcome. So you're Owen Hopkins, your sales director. Perhaps you could tell us a bit about the company Entegris before we start on the actual technology you work with.
Okay, well, thanks for having me, Brian. Entegris is actually a legacy of a companies that started from Millipore in the 1950s, as well as Floraware in the 1960s. And what's interesting about it is the companies were really started to look at some fledgling industries, one in particular, semiconductors.
So semiconductors, one field that you worked in, any other areas beyond the fuel cells where you have your expertise?
Well, our main expertise started in semiconductors, and that was a big reason why we came into the fuel cell industry 10 years ago, is we really wanted to get a good understanding and take some of the knowledge and understanding we have in manufacturing, contamination control, and purity of materials into the industry. That's why we felt fuel cells was a good fit.
Now, when some people hear semiconductors, they think computers. When other people hear semiconductors, they think materials.
Yeah.
And I see some materials here. I have to say I'm rather tempted to pick up this piece. It looks like a dark piece of sweet bitter chocolate and take a bite out of it. I'm sure it's not meant for that. What exactly is this? This is a very, very particular material, isn't it?
Yeah, and this piece is actually, this is high purity graphite. This is 100% pure graphite that we manufacture in Decatur, Texas. And what's unique about this material is that this is the only material in the world that's actually approved by the World Food and Drug Administration to be implanted in the human body.
Oh, so I could take a bite out of it.
It's up to you.
Okay. Yeah. Of course, this is a material that you use. What are the possible usages that you have for that graphite?
Well, this is a very interesting material because the applications for this have been used all over the world in very many different applications: aerospace, life sciences, other types of markets, optics for military applications as well. So we've been able to really utilize this material that really was started as a mistake. Was really meant to be used as a space tile in the Apollo and the Gemini missions, but they found out that the material didn't work very well. But they found out it was porous, and there was many applications for that.
So, of course, when I hear that I can take a chunk of that, insert it into the body, and it's not dangerous, I'm thinking probably non-corrosive. It doesn't rust. There's precious metals that you can use as well in certain cases, for instance, teeth. But this is a non-corrosive substance. So why is that so important for the fuel cell industry?
Yeah. Well, it follows the same theme. Every pacemaker, every heart valve in the world has some piece of poco graphite inside of it. Same thing with fuel cells. There's a purity, there's a requirement that you need to have the most natural and holistic materials that you can have available. And the longest lasting cell stacks are usually the ones that have some type of high purity graphite inside of them.
So it's one way of avoiding the issues of corrosion in a fuel cell that has to operate for a long time in contact with liquids and gases with the potential for corrosion.
Yes, reducing the metal ionic shedding that can sometimes adhere to the platinum catalyst, it reduces those issues, improves the life durability.
Okay, so you use this material. Now, do you have specific manufacturing techniques that allow you to use this material in many ways?
Yes, we have different types of manufacturing for this product where we can machine, we can pyrolytic coat, we can actually coat the material to do different things and behave a certain way as well. We can actually engineer the material to become more philic, to be more phobic, to adhere to more water or repel water.
You've got a few interesting examples on the table here. The first looks kind of like a beehive without the bees.
Yeah. And for people in the microelectronics industry, this is a pretty familiar piece. This is a matrix chip tray that's used in the manufacturing of chips. And what's interesting about this is why we got into the industry over 10 years ago, is the flatness and the parallelism on this chip tray, which is used to hold microchips, and then the robot will pick it up and then insert it into a circuit board. The flatness, the parallelism, all the tolerances on this are actually tighter than a bipolar plate that's used in a fuel cell system. That caused us to look at what we can do and be able to bring our capabilities to the industry.
Mm-hmm. And of course, you have another object there, which is the so-called bipolar plate. Of course, this is largely the heart of a typical PEM fuel cell. I'm assuming it's a PEM fuel cell.
Yes.
And could you describe what is actually so significant about the way that is manufactured?
Yeah, this is manufactured in Chaska, Minnesota, in Minneapolis, and we compression mold this material. And this material is about 80% carbon and about 20% vinyl ester. It's a binder to hold it together so that it can be compressed with a 700-ton press.
Mm-hmm. So this makes manufacturing relatively swift and easy?
In essence, it can, but it can't. It's a very challenging process when you're looking at that much carbon that's being put into a formulation, and you need to really have a high temperature and a high pressure to be able to compress that to the right precision.
Mm-hmm. And of course, the materials involved, for me, it's interesting because we're talking about graphite. Graphite is all over the place, but this is a very high-quality graphite. Does that mean that it is also expensive? This very, very pure graphite, is it a cost factor?
It depends, and everyone is very familiar. There are thousands of graphite suppliers throughout the world. There's Chinese graphite suppliers, there's European graphite suppliers, there's graphite that you use in your pencil. Those are different types of graphite. But the graphite we manufacture is a slightly porous material. It actually has a similar structure to the human bone. And so it actually is very strong and as well as light, and that's why it gives it that flexural, that tensile strength that it needs, and especially compressive strength for when you put it into a cell stack.
Mm-hmm. So there is some sort of issue about, on the one hand, cost, but then there's the payback. If you produce something that is just slightly more expensive but more durable, durability becomes actually a profitable option.
Right. Yeah, we want to be able to look at this material as it's never going to be a cost-effective material that's going to be exactly the same price as a compression molded material when we look at that. But we know that if we can provide you with a twice the life proposition, that's going to be a much better play, and as well as 3 times the life that you'd get out of an existing system, that's even more important.
Now, when I look at a graphic bipolar plate, I'm also thinking, okay, how often has this been already integrated into a system, a stack, and been up and running and tested? Have you got them tested?
Yeah, our materials have been tested for various companies over the last 10 years. We have hundreds of thousands of plates that we've made for this. We have tens of thousands of POCO plates that have been manufactured out of that material, being used in all types of different fuel cell applications, from portable to stationary to automotive applications.
And what's the feedback? Are they satisfied?
Very positive, and very positive on this material as well. The biggest complaint they have is, can you make it cheap? And that's something we're working on very hard to develop larger manufacturing processes. If a customer came to us 5 years from now and said, we are going to scale up and use that material, we would make that investment, depending on what the customer demands are. If the market wanted to move towards that, we have the ability, the space to do that, to move towards that using that material.
Of course, some of the materials that go into bipolar plates are really the precious metals, for example. There's always expenses involved. And optimally, you want to try and recover as much of, for instance, the platinum. You want to get back what you put in as best you can. Would it make sense, and is it possible to recover the graphite that you put in when you manufacture the graphite bipolar plates?
Yeah, absolutely. You can recycle this material, reuse it again if necessary. It may not be used in the same form again, but it could be used in other types of applications. It could actually be ground up again and maybe be put into this kind of material as well.
This seems to me significant because we do have catalysts on the market, and the problem is, in terms of scale, commercialization, there are some catalysts that are so downright expensive that if we start using those materials more often, the catalyst will become unaffordable. So there's no limitation to our sources of graphite in terms, if they're recyclable, we're not going to run out?
With this process, this type of graphite is actually from an oil refining process. We actually take the leftovers that are going to be dumped or dispensed, and we actually buy that material, that tar and that pitch, and we refine it into a highly pure material.
This is, by the way, a very noble, I call this garbage collectors, a very noble profession, because we're recouping resources that we've already invested, used, and recouping them is essential to that cycle. Manufacturing technologies are often developed and then applied as a skill to other fields. So when I hear you talking about the manufacturing of this, did you have manufacturing technologies in place that you could easily transpose into the processes involved in making these bipolar plates? Or did you have to really tinker with the manufacturing processes to get this thing up and running?
We did, and we had to make investments, major investments 10 years ago to look at compression molding. And then 3 years ago, we acquired Poco Graphite out of Decatur, Texas, to look at those materials for us to be able to move forward in various industries.
I should add, if there is any question in the audience about the bipolar plates, the technologies we're talking about, the graphite and its use, just raise your hand and we'll pass on the microphone. I'm certainly interested in knowing what many of the manufacturers are interested in knowing. We know that the options for applications in the fuel cell industry are many. Some of them still have to be discovered. It involves finding a niche market where there is a payback, a value proposition. For example, the combination of batteries and fuel cells has been entirely profitable. It's a commercially profitable way of using this technology to extend forklift truck life. There's all sorts of little applications there. But what this means is many people need flexibility in designing new products. That is, they often dream up ideas and they need to have the cooperation because small fuel cell companies can't do it all alone. We're always very happy when larger companies come along. But here's the question. Here's a bipolar plate. As one example, are you willing to tailor-make, to tinker that design in cooperation with fuel cell manufacturers to get a new, unique prototype onto the market with them?
Absolutely, and our goal is not to be able to take intellectual property. Our goal is to really help the fuel cell developers. We're a passive material supplier. We provide the materials. We work with them on their intellectual property that they've developed on a bipolar plate, their flow field design, their geometry, and then we will sign non-disclosure agreements and then be able to provide them estimates on what our estimate would be to produce that plate.
So I noticed actually when I was at your stand, this is not the only bipolar plate shape that you had on display.
Yeah. There's many different shapes, sizes. We can go up to various sizes from small postage stamp size all the way up to large 300 by 500 millimeter designs.
Postage stamp size.
Yeah.
That's fascinating.
Yeah.
Do you remember what that was for?
It's for a small military application.
Okay, all right. So you have many people who come to you as a resource for knowledge and know-how, and you cooperate from the R&D phase, help them to get that up and running.
Really from the concept to the commercialization phase. Yeah. So we'll work with them on the concept phase. They have a few ideas, maybe 2 or 3 prototypes that need to be made, and then we'll work with them on the higher, of the higher volumes that are necessary.
Now, whenever I talk to companies like yours, because Entegris is a large company, by comparison with the typical fuel cell company, it is a good factor of 10, at least.
We're a $750 million a year company, and I'm responsible for 1% of the business, so I'll let you do the math.
Okay, all right, there you go. But what this boils down to is large companies. It's my conviction the fuel cell industry would not actually be able to survive without being able to go to charitable, I'm talking emotionally, not financially, but who are kindly enough to help us in developing things. But one has to ask, I mean, companies can't afford to do this just because it sounds like a nice thing to do. It's like helping an old lady cross the street who then turns around and crosses the street again. The fuel cell industry has been developing and developing, and I think someone from a larger company who gets involved has to have some sort of conviction that we're actually going somewhere. We're not going to turn around and cross the street again. What we're going to do is arrive at a point where the commercial products make it another business factor for your company, another revenue source. So this complicated question is really twofold. Has it been financially an investment so far? And how strong is the conviction that this investment is going to turn into a real source of income in the near future, perhaps?
Yeah, it has been an investment for us. So for the last 10 years, we have invested, especially in the early years, in equipment and materials that need to go into the technology. We have invested a lot of money into this, but we're still feel that long term, this is an industry we want to be able to serve, and that's why we're still in this industry, and we expect to be in this industry for a long time.
Now, on a philosophical, we're almost at the end. Again, if there is any question from the audience, just raise your hand. The philosophical issue at the end is, what's going to come first? Have you any convictions about whether the stationary applications are going to break the ice or the mobile ones? Why this is such a significant debate is we know prices are going to change when there's mass production. Infrastructure for hydrogen is not going to be in place until we have a certain quantity that makes that viable. And even the production of hydrogen is going to change when it's used as a methodology for storing electrical power, for instance. Very, very current philosophy in Germany. Something's going to happen, but among those things, it's going to be the applications, I think, that drive this as well. So any sense of what your favorite mobile or stationary application would be?
Yeah, I mean, the industry's been a real passion of mine, and you really see some different things that have changed over the last 3 to 4 years. I think forklift material handling has been one that has a real niche area that's been able to prove their value over batteries or lead acid batteries. I think those are the areas where the industry has to stand on their own 2 feet. Yep. And we have a certain number of years. We have some government incentives to investment tax credits, but it's all up to us, and especially the material suppliers, to work with the developers to help meet those targets. I usually use the mental term December 31st, 2015. Some of those tax credits may disappear. Are we going to be prepared to be able to help get those costs down to where they need to be so that the fuel cell developers can move forward and they don't have to rely on that, so the industry really starts to take off?
Yes, and we're very proud of those commercially viable. You mentioned the forklift trucks. We're so proud of these achievements, of course. Yeah. But again, I have to remind the industry here and the people in the audience, we wouldn't be there without the aid of companies such as yours with simply the means and the specialty, the materials knowledge. And being prepared also to put that all to work for a market that is not yet, but will be. So we thank you very much, Owen Hopkins, for your involvement in the industry.
Thanks for having me.
And I hope to see you back next year. Take care. And thank you for listening. We have reached the end of our program. It's been an exciting day. We've heard from another sector in this field. Very exciting. We hope to greet you again tomorrow. We'll be back, I believe, at 10:20, the first talk tomorrow. And it's all on the plan here. Another day of informative interviews. Thank you for your time, and have a good evening.